Greetings, doctors. I am TEW JIAN from Group 2, and our group consists of NARINDERJEET, SINGH, and DAHUA. Today, we are introducing Intel i7 6th Gen 700 processor. Intel Core processor families have three main chip families, which is Core i7, Core i5, and Core 2. All are based on the 45nm technology that Intel started moving to in late 2007. Intel hoped to phase out the Core 2 line of products and introduce a new entry-level processor called i3. The naming of the Core processor is shown as below. Intel Core which is the brand, and i7 is brand modifier. The number highlight is generation indicator, followed by SKU numeric digits and product line suffix. So for Intel Core i7 processor, Core i7 represents Intel high-end performance processor. Core i7 processor offers the most complete set of the features, include hyper-threading technology that gives the chips the ability to execute 8 threads simultaneously on 4 processing cores, better power management, and an integrated memory controller. Intel Core i5 processor are the mid-range performance processor with performance higher than those offered by Core i3 but below than Core i7. Core i5 processor usually have more cores than i3 and offer more features such as turbo boost technology. Intel Core i7 processor are considered as the performance processor but generally sit low side of the scale. They sit below the Core i5 and as well as i7 families. Core i3 family makes it very decent for multitasking and budget gaming processor. These chips don't have some of the advanced features such as turbo boost. In this table, we have compared some of the specifications of Core i3's family, Core i5 families, and Core i7 families. In terms of number of cores, the i7 families have 2 to 4, and also Core i5 families have 2 to 4, but the Core i3 families only have 2. The range of the frequency of Core i3 is the lowest, the maximum range. And for the Core i7 families, it can until 4 GHz. For i3 families, they support hyper-threading technology. For i5 family, they support turbo boost technology. For the i7 family, they support both of the technology, which is turbo boost and hyper-threading. In terms of cache, i3 families only have 3 to 4 megabit. For the i5 family, they have 3 to 8 megabit. For i7 family, they have 4 to 8 megabit. In terms of number of threads, i3 families and i5 families have 4 of the 4 threads. i7 family have 8 threads. In terms of size, the data shown here is the older version. The latest version of every families, which is i3, i5, and i7, the smallest size can reach to 14nm silicon. For the graphic of the i3 is low, and which is considered the price is very low. And the i7 families is a high-end processor, so the graphic must be best and also expensive. For the advantage of i7 core processor, it has big cache size. i7 core processor has 8 megabit last level cache share among 4 cores, and this helps to increase instruction execution speed. And i7 core have high performances, combining of Intel Turbo Boost technology and Intel Hyper-Threading technology processor. Speed is more faster than compared to other processor. i7 core processor have better cooling system. It has 4 pin connectors. It includes for fan speed control to help minimize the noise level generated from running the fan at a higher speed. for thermal performance. Intel Core i7 6700 is the Intel 6th generation central processor unit. It used 14 nanometers, second generation FinFET transistor technology to build microarchitecture. The 6th generation Intel Core i3, i5, i7 processors are used Skylake microarchitecture, and it is launched at 2015. The chip specification: this chip consists of 4 cores, 8 threads. The max probable speed, the clock frequency is 4 GHz, and the processor base clock frequency is 3.4 GHz. The cache memory of this processor is 8 megabit. The bus speed is 8 giga transfer per second, and thermal design power is 65 watt. The onboard graphic is Intel HD Graphic 530. Graphic base frequency is 300 MHz, and graphic max dynamic frequency is 1.15 GHz. The bus 8 giga transfer per second, and thermal design power is 65 watt. The onboard graphic is Intel HD Graphic 530. Graphic base frequency is 300 MHz, and graphic max dynamic frequency is 1.15 GHz. The bus 8 giga transfer per second, and thermal design power is 65 watt. The onboard graphic is Intel HD Graphic 530
of 8 MB. Its max thermal design power is 91 watts. So it is capable of 2 DDR4 DRAM memory controller, which is 34.1 gigabytes per second max memory bandwidth. It is come with integrated 3D graphic processor running at about 350 MHz to 1.15 GHz. It is pipeline bus on chip network connecting cores, last level cache banks, and GPU. This is the Skylake core microarchitecture overview. So the Skylake core extends the Broadwell microarchitecture to deliver higher instruction per cycle, higher frequency, and a wider dynamic power range. The core becomes wider and deeper in a power efficient way, bringing more performance into lower thermal power envelopes. Basically, it means that Skylake is better than Broadwell. So Skylake support a more aggressive instruction prefetch that reduces the penalty of instruction cache misses. Both the legacy decode pipeline bandwidth and the micro-op cache bandwidth are increased. The legacy decode pipeline peak bandwidth is increased from 4 to 5 micro-ops per cycle, and the micro-op cache peak bandwidth is increased from 4 to 6 micro-ops per cycle. Skylake improved LSD, which is loop stream detector mode, which play loops with a small loop body directly from the micro-op queue, thus turning off the rest of the front-end's clock. By increasing the size of the micro-op queue from 88 to 64 micro-ops per thread, Skylake increases the LSD coverage, saving more power. Ring interconnect. So ring interconnect between cores, graphic cache, and increased bandwidth. This ring wire routing over the last level cache with no error impact. The access on ring always pick up the shortest route to reduce latency, better upgradability to a larger number to processor. This is the Skylake core microarchitecture individual core. Skylake adds multiple improvements in the core's front end for supporting higher bandwidth instruction supply, thus reduce branch miss prediction penalties and reduce instruction cache miss penalties. Skylake's branch predictor accuracy is improved and its capacity is increased. Furthermore, the penalty for mispredicted direct jump targets is reduced. The decoder can read two 16-byte blocks of code per clock cycle from the 64 bytes buffer, so that a total of 32 bytes can be decoded in one clock cycle. But the output of the pre-decoders is limited to 16 bytes or less per clock cycle, so that the decoders can only receive more than 16 bytes in one clock cycle in linear code if they process less than 16 bytes in the preceding clock cycle. There are 5 decoders. The first decoder can decode instructions that generate up to 4 loops. The other 4 decoders can decode only simple instructions that generate a single ops. The maximum throughput from the decoders is 4 instructions or 5 ops per clock cycles. The minimum throughput is seen in a sequence where all instructions generate 2 ops each, so that only the first decoder is active.
Okay, now I'm going to continue from Brandon to explain about the decoder. The decoder can read 260 bytes blocks of the code per clock cycle from the 60 bytes buffer, so that a total of 32 bytes can be decoded in one clock cycle. But the output of the pre-decoder is limited to 60 bytes or less per clock cycle, so that decoder can only receive more than 60 bytes in one clock cycle in linear code if they process less than 60 bytes in the preceding clock cycle. There are 5 decoders. The first decoder can decode instructions that generate up to 4 microops. The other 4 decoders can decode only simple instructions that generate a single microopt. The maximum throughput from the decoder is 4 instructions or 5 microops per clock cycle. The minimum throughput is seen in a sequence where all the instructions generate 2 microops each, so that only the first decoder is active. We have a function in the core called macro ops fusion and micro op fusion. The decoders will fuse arithmetic or logical instruction and the subsequent condition jump instruction into a single compute and branch micro op in certain case. The compute and branch micro op is not split in two at the execution unit, but executed as single micro op by the branch unit at execution port 0 or 6. Some instructions that need 2 microops in the execution unit can use micro fusion technique to keep these 2 microops together as one from the decoder to the reservation station in order to save pipeline bandwidth. We also have the stack engine. The modification of the stack pointer by push, pop, call, and return instruction is done by a special stack engine, which is placed immediately after the decoding stage in the pipeline. An extra stack synchronization micro is inserted automatically when the stack operations such as push, call, or return are interspersed by the instruction that access the stack pointer specifically, such as add RSP8 or move EAX RSP plus 60. Okay, we come to the execution engine. This is the execution engine. Execution engine of the Skylake improve the bandwidth and reduce the latency of many arithmetic EUs. The throughput of division operation increased by 1.67 to 2.33 times, depending on the data size, depth, and size. A Skylake has a number of the execution unit accessed through 8 execution ports. This gives a maximum throughput of 8 microops per clock cycle in the execution units. There are 4 integer ALUs, so that the most common integer operation can be executed with a throughput of 4 instructions per clock cycle. There are 3 ports that can handle integer vector operation up to 256 bits. 2 ports can handle the floating point vector operation. 2 ports can handle branch. 2 ports can handle memory read operation, and 1 port can handle memory writes. Okay, this one is the scheduler. Skylake allocate 4 microops per cycle into the instruction scheduler, which is in charge of dispatching microops to the execution units, and into the recorder buffer, which is in charge of the faulty handle and retirement. Compared to last generation instruction, the scheduler is increased from 60 to 96 microops, and the recorder buffer size increased from 192 to 222 microops to 224 microops. The instruction scheduler entries are active on demand, which by means of the clock gating, thus saving power when not used. The integer register file increased from 168 to 180 entries. They also have a function for register allocation and renaming. All integer, floating point, vector register, flag, and perhaps also segment register can be renamed. The floating point control words can also be renamed. The register rename is controlled by the recorder buffer under the scheduler. This one is the memory system of the core. Skylake core memory subsystem improve the performance of the load and store operation. For load operation, Skylake reduce load to store to load forwarding latency, significantly reduce page split load penalty. For store, Skylake use deeper store buffer to increase store throughput and issue the request to the L2 cache for store that missed in the L1 cache earlier, thus reduce the store miss penalty. Skylake also increased the bandwidth from the in-core L2 cache into the shared L3 cache, which allowing higher stream store bandwidth. It also can do multi-threading. Larger version of the processor can run 2 threads in each of its cores. This means that each thread gets only half of the resource. L1 level 1 cache, instruction fetch, decoding and execution unit are shared between 2 threads running in the same core at the same way in the previous generation of the processors. This one is the processor graphics. Skylake achieve better energy efficient. We take the higher level view of the graphic architecture. The architecture is partitioned into 2 major domains: unsliced and sliced. The fixed function are in the unsliced. The rendering, computation, and programmable media function are on the slice. So this one is the slice. The blue part is the unsliced. So in conclusion, the Skylake Core S7 outperformed the fastest Core 2 Extreme processor. It has the advantages of high performance, highly overclocked, quiet cooling, and power efficiency. It is a fairly modern architecture of CPU and managed to handle normal tasks on computers. But current architecture of CPUs are much powerful than the 6th generation CPU. That's all from us. Thank you very much for listening.